Download this code from codegive.com, link in the description below. Generating parse JSON schema dynamically in Power Automate with code examples. This tutorial will guide you through the process of dynamically generating JSON schemas for the parse JSON action in Power Automate. We'll explore the reasons why this is valuable, the different methods available, and provide detailed code examples with explanations to help you implement this powerful technique. Why dynamically generate JSON schemas? The parse JSON action in Power Automate is crucial for working with JSON data. It converts a JSON string into a structured object that you can then access and manipulate within your flow. However, it requires a predefined JSON schema to understand the structure of the JSON data. Hardcoding this schema works well for simple, static JSON payloads. But when you encounter scenarios with dynamic JSON structures, the JSON schema changes based on the API endpoint, user input, or a configuration file. Varying properties, the JSON payload may contain different properties depending on certain conditions. Large and complex JSON manually creating a large JSON schema can be tedious and error-prone. Reusable flows, you want to create reusable flows that can handle different JSON payloads without modification. In these situations, dynamically generating the JSON schema is the solution. It allows your flow to adapt to changing JSON structures, making your automation more robust and flexible. Methods for dynamic schema generation. There are several approaches to dynamically generate a JSON schema in Power Automate. 1. Using a JSON editor control with Generate Schema, manual but helpful. This is a semi-dynamic approach, more suitable for discovery and understanding the schema initially. Place a compose action in your flow. Paste a sample JSON payload into the compose input. Click the generate from sample option. Power Automate will automatically create a JSON schema based on the sample. You can copy and paste this generated schema. While not fully dynamic, this is a great starting point for understanding the structure and customizing it further. 2. Using compose actions and string manipulation. This is a common approach that involves constructing the JSON schema as a string using compose actions. You build the schema piece by piece using expressions, variables, and conditional statements. Pros. Good control over the schema. Relatively easy to understand. Cons. Can become complex for very large and nested JSON structures. 3. Leveraging JSON and schema functions for basic cases. If your JSON payload is somewhat consistent, you can try using the JSON and schema functions to derive a basic schema. JSON converts a string to a JSON object. The schema function, currently more limited in its capabilities, can sometimes extract a schema from a JSON object. However, it's important to note that schema often produces a basic schema that lacks specifics like data types and can be unreliable for complex structures. Pros. Simple for very basic scenarios. Cons. Limited capabilities. Often requires manual adjustments. Not suitable for complex or dynamic schemas. 4. Using Azure functions, most powerful and flexible. Create an Azure function that accepts a JSON payload as input and returns a dynamically generated JSON schema. Power Automate calls the Azure function, retrieves the schema, and uses it in the parse JSON action. Pros. Maximum flexibility and control. You can use any programming language supported by Azure Functions, Python, JavaScript, C, etc., to generate the schema. Ideal for complex scenarios. Cons requires familiarity with Azure functions. Adds complexity to your solution. Involves additional Azure resource costs, although often minimal. Detailed examples. Let's dive into detailed examples for the most practical approaches, using compose actions and string manipulation, and leveraging Azure functions. Example 1, using compose actions and string manipulation. Scenario *, you receive JSON data from an API that contains product information. The price field may or may not be present in the JSON response. We want to dynamically generate a JSON schema to handle both cases. Flow steps *. 1 HTTP action *, get the JSON data from the API. Assume the API endpoint is https://example.com/products/123. 2 Compose, sample JSON, optional. This is for testing and visualizing. Copy the JSON from the HTTP actions body. 3 Condition * check if the price field exists in the JSON. * expression, contains, string, body, HTTP, price. 4 Compose, schema with price, true branch. If the price field exists, create a JSON schema that includes it. 5 Compose, schema without price, false branch. If the price field does not exist, create a JSON schema that excludes it. 6 Parse JSON *. Content, body, HTTP, the JSON data from the API. Schema. Expression, if, contains, string, body, HTTP, price, outputs, compose, schema with price, outputs, compose, schema without price. Explanation *. Step 1, HTTP action retrieves the JSON payload. Step 2, compose, sample JSON useful for manually examining the JSON structure. Step 3, condition checks if the price field exists in the response. We use contains to check if the string representation of the JSON body contains the string price. Step 4 and 5, compose, schemas. These create the JSON schema string, one with the price property and one without. Carefully define the data types and required fields. Step 6, parse JSON. This is the crucial step. The schema field uses an expression. The if function checks the same condition as in step 3. If true, it uses the schema from compose, schema with price, otherwise, it uses the schema from compose, schema without price. Outputs, function retrieves the result of the compose actions. Important considerations for compose-based schemas *. Data types * ensure you define the correct data types in your schema, example string, integer, number, boolean, array, object. Required fields * the required array specifies which properties must be present in the JSON data. Handle missing required properties gracefully, example by providing a default value or logging an error. Nested objects and arrays * for complex JSON structures with nested objects or arrays, you'll need to create nested schemas within the properties section. This can make the schema creation more complex. Escaping special characters * be careful about escaping special characters within your schema string, particularly the \\. Power Automate can be sensitive to incorrect escaping. With espace *. While JSON is generally white space insensitive, excessive white space can sometimes cause issues in Power Automate expressions. It's generally best to keep the schema strings compact. Example 2, using Azure functions. This is the most powerful method for handling complex or highly dynamic JSON schemas. Steps *. 1. Create an Azure function *. Create an Azure function in the Azure portal or using Azure Functions core tools. * Choose a language like Python, JavaScript, or C. Python is generally a good choice for JSON manipulation. * Configure the function to be triggered by HTTP, an HTTP trigger. 2. Azure Function Code, Python example. Explanation of Python code *. Import libraries *. JSON for working with JSON, logging for logging. Main function *. This is the entry point for the Azure function. It takes an HTTP request object as input and returns an HTTP response. Get JSON payload *. Req get _ JSON, attempts to parse the request body as JSON. Error handling is included in case the request body is not valid JSON. Dynamic schema generation logic *. The if price in req _ body block demonstrates a simple example of generating the schema based on the presence of the price field. You can replace this with any logic you need to determine the appropriate schema. This is the core of the dynamic schema generation. You analyze the incoming JSON and build the schema accordingly. Return schema as JSON JSON.dumps, schema, converts the Python dictionary schema into a JSON string. The MIME type equals application/JSON ensures that the response is properly formatted as JSON. Local testing * the if ___ name __= main ___ block provides example code for testing the Azure function locally using the requests library. Important * replace http/localhost 7071/API/http example with the actual URL of your function when running locally, and adjust the sample JSON. You'll likely need to install the requests library, pip install requests. 3. Deploy the Azure function * Deploy your Azure function to Azure. Get the function's URL, you'll need this in Power Automate. 4. Power Automate flow *. HTTP action * Get the JSON data from the API, same as in example 1. Or use any data source. HTTP action, Azure function. Method, post. Query, the URL of your Azure function. Headers, content type, application/JSON. Body, HTTP, the JSON data from the API you want to parse. Parse JSON content, body, HTTP, the original JSON data. Schema, body, HTTP _2, the JSON schema returned by the Azure function. Note, HTTP _2 refers to the name of the HTTP action that calls your Azure function. Adjust if needed. Explanation of Azure Functions approach *. Azure Function as schema generator *. The Azure Function acts as a schema generation service. It receives the JSON data, analyzes it, and constructs a JSON schema that accurately represents the data structure. Separation of concerns *. The schema generation logic is completely separated from the Power Automate flow. This makes your flow cleaner and easier to maintain. Flexibility * You can use any programming language and any libraries you need within the Azure function to generate the schema. This provides maximum flexibility for handling complex scenarios. Power Automate Orchestration. Power Automate handles the orchestration of the process, fetching the JSON data, calling the Azure function, and then using the generated schema to parse the JSON. Choosing the right method. Simple scenarios. If you have a very simple JSON structure with only a few possible variations, using compose actions and string manipulation might be sufficient. Moderately complex scenarios. If the JSON structure is moderately complex, consider breaking down the schema into smaller parts and building it incrementally using compose actions. Also, the schema function might be helpful in quickly generating the initial template for further customization. Complex or highly dynamic scenarios. For complex JSON structures, highly dynamic schemas, or situations where you need to perform complex data analysis to determine the schema, using an Azure function is the best approach. Best practices. Error handling. Implement robust error handling in both your Power Automate flow and your Azure function. Handle cases where the JSON data is invalid, the schema generation fails, or the API returns an error. Logging. Use logging to track the schema generation process and to help debug any issues. Testing. Thoroughly test your flow with a variety of JSON payloads to ensure that the schema is generated correctly in all scenarios. Schema validation. Consider validating the generated JSON schema against a JSON schema validator to ensure that it is valid and conforms to the JSON schema specification. This can help prevent errors during the parse JSON action. There are several online JSON schema validators you can use, or you can use a library within your Azure function. Use comments in your JSON schemas. Well-commented JSON schemas greatly improve readability and maintainability. While JSON itself doesn't natively support comments, you can add custom properties, example_comment, this is a comment, that are ignored by the JSON parser but provide helpful explanations. By using these methods and best practices, you can dynamically generate JSON schemas in Power Automate to handle a wide variety of JSON data scenarios and make your flows more robust and flexible. Remember to carefully consider the complexity of your JSON data and choose the method that best suits your needs. Good luck.